Hi, this short video is about the ballast that we've got in here. Our boat, it was designed to take 3 tons, or needing 3 tons of ballast. Our options being concrete blocks, but I'm not keen on those for environmental reasons. And anyway, what I've come up with is I've used the blocks that are extracted from old night storage heaters. And they weigh 7 kilos each. And the actual blocks fit perfectly between my stringers, as you can see here, that they're a good fit under the lip of the stringer, and they come across here and give me a nice flat surface to work on from there. And it works out we get 24 per bay, per stringer, and we've got 19 stringers. We're not filling the back stringer by the motor to allow for that. So we end up there with 425 blocks we're looking for. And if you do the maths for that, that comes out at 3,024 kilos. So that's where they're put in. And the reasons, advantage with this, because it's about twice as dense as a concrete block, it'll mean that we need, whereas a concrete block to give us our 3 tons would be 100 mm on the floor, we're now 50 millimeters. So we gain 50 millimeters height-wise, which is good for the insulation on there. So here's the last 100 bricks that have got to go in. They come, kept them dry because it seems like a good idea. And there's the stacks of insulation for it. To check porosity on this, because I was concerned about porosity, is that what I did was to do it by volume. So basically got a known measure, 500 ml, got blocks, covered them, left them for 24 hours, and you get a little bit of porosity as they fill up any air gaps in there. But after 24 hours I came to measure it back out again, and actually it only absorbed about 2%, which is probably better than a concrete block on that, so I'm happy with that. What it's made from is that it's made from slag out of, I believe it to be slag out of the steel making processes on there. You can see there, that one stopped fizzing and bubbling, so that's it. It's basically fairly impermeable, so that's fine. And the reason we got for a flat deck on there is because the insulation we're going to use on there, rather than have ribs going across, the insulation fitted between, I'm actually putting in a raft of insulation to improve the thermal properties of it. So once you've done that, you've soaked them 24 hours later, you take your bricks out of there, pour your fluid back into your known measurement, we're back virtually where we started from, so I don't think I'm going to get better than that. So that's the science. I should also add, out of interest sake, is that the blocks are available virtually free of charge. If you look at Facebook and Marketplace there, I'm picking them up from electrician installations where they're upgrading storage heaters, and they have to dispose of these things. And I've been paying one lot, I've 100 I paid for £20 for, I've given £70 for 160, so they're fairly cheap in comparisons with other material in there. And one of the reasons why I'm wanting a flat deck on here, whereas normally you'd end up with timber framework, stud work, and then you put your floor decking on top of that. We're not wanting that. What we're going to do is we're going to make a complete raft of insulation on top of the stringers on here, and then the floors laid on top of that. It's a modern way that they're building houses at the moment. The same with the roof. The roof will be lined, infilled, and then fitted with another sheet, 25 mm sheet, but it won't penetrate through these. These will be spaced off and screwed into here to retain the roof lining directly on, just on the studs, so we've got the thermal break all the way through, because of course really important to get thermal properties right on the floor and the ceilings for obvious reasons.